Hey friends, what's up? So today we are talking about greatest common factor and least common multiple word problems. So I've got two examples here for us. We're going to go through based on the notes, look for those keywords, highlight them. We're going to identify what type of problem it is, whether it is GCF or LCM, and then we're going to solve. So these problems are very similar to some in our notes, but also they're very similar to two of the problems that are on your worksheet of extra practice problems that is on Canvas. So with all that being said, let's just jump right in. So for this problem, let's read it through, and then we're going to talk about those keywords that we see that might give us a hint at what type of word problem it is, whether it's GCF or LCM. So I have 40 Butterfingers, 10 Snickers, and 24 Sweet Tarts that I want to distribute to students. I want to give an equal amount of Butterfingers, Snickers, and Sweet Tarts to each student. What is the highest number of students that I can give some goodies to? And how many of each treat would the students get? So let's think about our notes. If you haven't already filled them out, please pause this video and go do so, or pull up the answer key on Canvas. But if you have your notes, I'm going to start talking about those keywords. So you have a little chart that gives you some phrases and keywords that you should be looking for each type of problem, whether it's GCF or LCM. So looking back through it, we obviously have our three numbers. So this particular problem is going to have a three number ladder. Now going through it says we want to distribute, which means we're giving them out. We're going to distribute. But when we distribute, we want to give an equal amount. That is a super important keyword. Anytime you see equal amount, it means we're dividing things up into groups. And then also, what is the highest number? Highest is a synonym for greatest. So with all of this being said and all of our highlights, what type of problem is it going to be? If you look at your notes, you should be able to tell that this is a GCF word problem. So now that we know what we're solving for, let's set up our ladder. We've got 40, 10, and 24. And then bringing it down and over. All right, so based on the video from yesterday, we know how to solve using the ladder method. We're going to start to think of a number, or otherwise known as a factor, that could go into all three of these digits. If you notice, they're all even. So the easiest place for me to start is with a 2. So let's factor out that 2. 40 divided by 2 is 20. 10 divided by 2 is 5. And 24 divided by 2 is 12. So now let's look and see if there is another factor or another number that can go into all three of these numbers evenly. Unfortunately, there's not. So this is actually where we stop. Because we're stopping and we're solving for GCF, you're going to make your G on the side. And there's only one number in our G, which means that our GCF equals 2. So because they're word problems, this is actually not your final answer. If you notice, there are some blanks over here that we have to fill in. And there was actually another question that we have to answer. So the GCF, that is actually telling us the number of students. So that first question asked us, what is the highest number of students that I can give some goodies to? This 2 represents the 2 students. It's 2 groups. So that's where we got that 2 from. Now we're trying to figure out the number of Snickers, Butterfingers, and Sweet Tarts. We get those numbers from this bottom rung of the ladder. We started with 40 Butterfingers, so right below it is 20. So now there are 20 Butterfingers. Snickers, there were 10. And once we took out that 2, we now have 5. And Sweet Tarts, we started with 24, we factor out the 2, and now we have 12. So this is our final answer for this first word problem. Now I'm going to scroll on down to our second word problem. So same deal. We're going to read through the word problem and highlight those words, those keywords and phrases that we see that might tell us whether or not we are solving for GCF or LCM. So let's go ahead and get started. Tom mows the grass every 4 days. Joe mows the lawn every 10. They both mowed the lawn today. How many more days will it be before they mow the grass on the same day again? So let's go back through it. We've got our numbers here, 4 and 10. Okay, so we know that we're going to be dealing with those numbers. Tom every 4 days and Joe every 10 days. But looking at the question itself, how many more days will it be before they mow the grass on the same day again? If you refer back to your notes, on that LCM side, one of the keywords and phrases that it said you would see for an LCM word problem is something happening over and over again, or a repeated event, or something happening at the same time. So in this case, same day. So because of all of that, now we know that we are solving for the LCM. So now let's go ahead and just set up our ladder with 4 and 10. Starting off, look for a factor. Think about a factor that would go into both of these. Again, they're both even numbers, so I know that we can factor out that 2. So 4 divided by 2 is 2, and 10 divided by 2 is 5. Because we can't go any further, there's not another factor that 2 and 5 have in common, we're actually done. So now we can make the L because we are solving for LCM. When you're making your L, you're taking everything on this far left side outside of the ladder and going to the bottom rung of the ladder. Okay, so now we have to multiply all those numbers in the L. So 2 times 2 times 5. If we break that down, 2 times 2 gives us 4, and we bring down that times 5. 4 times 5 is 20. So our LCM equals 20. But LCM equals 20 is not our answer. In this problem, it's not asking what is the least common multiple. It's asking for how many more days will it be before they mow the grass on the same day again. So the answer to this question is actually 20 days. Remember, when we're dealing with word problems, it is very, very important that your answer is in the context of the problem. Yes, LCM equals 20 is technically right, but because it is a word problem, we do expect you to put it in the context. The question's asking how many more days, so your answer should be talking about days somehow. So these were 2 examples of how to solve a GCF and an LCM word problem. If you need any extra help, please rewatch the video and make sure you fill in your notes. Bye, guys.